right, guys, I'm extremely excited about our guests here today. I think this is going to be a fantastic episode. I know it is for me because being a gearhead, I love data, I love tech side of things, and today we have Phil and Ryan from SBI with us. We're really excited and appreciate you guys coming on. So it's a lot of things to talk about. SBI is a huge business. It's a big business, and anybody in the engine building business or racing industry or anything like that, they're familiar with SBI. So tell me a little bit kind of how SBI got started.
Great. Well, thank you for having us. It's a great opportunity. SBI was, it's an exciting time for SBI right now. We're just about to celebrate our 40th anniversary. So in 1982, there was a demand for valve seat inserts, heavy-duty applications especially, but also on the automotive side. The removal of lead out of our fuels had began to take effect on the cylinder head area. And without having an additional hardening of a valve seat insert, the castings were failing and just pulling through and burning up there. So there was an immediate need for that, so the founders started with a 2-page catalog. And now, almost 40 years later,
awesome.
We've got almost 1,300 pages in the catalog now.
Y'all have been busy.
We've been real busy.
That's awesome.
The timing sequence, obviously there was more demand for other items, mating components. And then in 1990 we started, the original was J-Loy, the seats, and then we moved into E-Loy with the valves. And then shortly thereafter we started a Head Start program, which brought in all the retainers, the springs, the valve guides, things of that nature to complete the offering. Then in 2001 we acquired Dynagear Corporation, which included Ertl, Nyland, and Ohio valve guides. So we took on all of their intellectual properties and learned a whole lot about valve guide manufacturing and alloys to work with. So ever since then, we've just been off and running and trying to get better and better in the valve training area.
That's awesome. So how long, Ryan, have you been with SBI, and what was kind of your tenure there, and how did you get started?
I'm in my 15th year. Started in the quality control side. I had a background in engineering, so working through the quality control side, learning specifications, learning the standard in which we maintain was the stepping stone in the ability to reverse engineer and start to design the goods. So I've had a long run of drawing them, answering a lot of tech lines over the years, and then I was at the head of the department as far as product is concerned, and then had the opportunity to be the president. So started from here and ended up here. And
that's awesome.
15 years, it's been great.
Yeah, that's really neat to see somebody work their way up through the company. There's so much opportunity, especially today.
Yeah.
You know, I think I was talking to my brother-in-law. We were talking about different ways of interviewing people, and one of the main things that I see that makes a really good employee is a guy that's excited about the business that he's in, and he's done his homework when he walks in. And he said, "What would your response be if a guy came to you and said, hey, where do you see, if you're interviewing him, said, where do you see yourself in this company?" And he said, 5 to 10 years, I want your job. I want to be the CEO. It's like, that'd be great. Sure, absolutely. Yeah,
that's a great answer.
Yeah, we look forward. We like anyone with some ambition, and really, this company's been wonderful to me, and it's certainly paid off.
That's awesome. How about Phil? How did you and SBI kind of come together?
Been with the company 3 years now, and I worked engine bearings before coming to SBI. I worked gaskets and seals in the aftermarket before I did engine bearings. So while I've only been with Ryan and the crew here for a few years, I've been around the aftermarket for many, and have had it's neat to be able to work through different sections of the motor so that you understand exactly everything that you're going to be experiencing from top end to bottom end,
right?
As well as working with our customer base and our PERs and our distribution partners. So it's been a very good run, but I very much enjoy the time that I've had here. Look forward to many more years. SBI is such a well-branded piece that is synonymous with quality, that it really makes it a joy to work with that. I know everybody steps out and wants to have a quality piece, but there's different measures of that.
Yeah, absolutely. Well, SBI has definitely been a part of our success, and we greatly appreciate the product that they put out and the service that that y'all provide. Everybody knows in the gas burner world, SBI, and I think that the diesel world, especially the heavier stuff, I know that y'all have had that's part of your market as well there. But for us and the guys, that are watching, are probably watching, the guys would own a Ford Power Stroke, Chevy Duramax or GM Duramax, or Cummins engine. So y'all have a big foothold in that industry and that market as well. And you've got some really neat products there. So kind of give me a little bit of the lineup that you have for the things that we use. Now I'm familiar with some of the products, but I love to be able to sit back and listen and hear, especially from the guys that have done the engineering side of the things and the quality control side of things. And tell us a little bit about the tech on that.
Yeah, the 6.0 is what I brought today, and it's just a little bit of a show and tell. Obviously, we've got a complete offering for all of the mentioned applications, Cass. We've got injector sleeves for all the mentioned applications, obviously the guides, the seats, valve springs. We jumped into retainers. We've got all the locks. For those that might have an integral guide, we partner with tooling companies and make sure that there are tools available to install and or remove the bosses and then get in a fresh solid state guide back into that to get your concentricity back. Outside of that, we do like to have a little bit of fun. We're typically known for replacement product. We try to meet our commitment is to meet or exceed the OEM standard. But we also like to have a little fun, so we do jump into the performance side of these applications as well. The stock valves were obviously workable. They do their job and have their purpose, but they were this intake valve from Ford is really basic chromium steel valve with a chrome plate on it. Does its job, but we like to, for the guy on Saturday night wants to add a little bit of boost, we've taken this into a two-piece valve and went to a 21/4N stainless steel, which would typically be synonymous with an exhaust type material, but we know things can get a little hot, and everybody likes to put a little boost, so we wanted to upgrade this thing so it can handle a little more heat and be a little bit better with the corrosive nature of the applications as well, and hold up in those environments.
Yeah, so that leads me to a little bit of a segue. So we see a lot of times when we were taking valves out of heads, the factory valves, some of the things that we see now, for the guys watching, when you mention the words corrosive, the first thing that does come to my mind is the sulfur and the ultra low sulfur diesel. So, Phil, it's interesting hearing you talk because you're well rounded, because you've got, the gaskets and the bearings and now the valve train. So you've been all over the engine. And one of the things that people don't realize is that an engine is a system. It is not an isolated event. That valve train shares, it's touching everything. And everything that touches it has a bearing on it. So if you change one small thing on the engine, and it's not just the thing on the engine, it can be the thing in the gas tank or in the fuel tank. That has a complete, it has a ripple effect throughout everything else. One of the things that we see a lot of times on the factory valves are the corrosive pitting that you see, and that's from the sulfur in the fuel. Now they're going to an ultra low sulfur since back in 2008, somewhere in there. Is that about right?
That's about right.
Yeah. So tell us what what kind of protection that valve provides from some of that corrosion that we're seeing.
Absolutely. Typically, and we can segue it again back with the valve guides themselves, was the initial issue we found with the ultra low sulfur diesel, and we'll touch on that a little later. But with the upgraded materials, obviously, they didn't require a hard seating surface or like a stellite or anything like that, but just the ability to maintain. We nitride the valves as well. We started seeing this in European diesels some years back, and not really common practice in America at that point was just the additional process of nitride. Many of the OEMs in America would grind off the seat face, grind off the tip, portions where they were going to be in constant contact and wear on those. We really can't figure out why. It's a much better process and or a much better result with the wear inhibiting is leaving them in place. Typically, and again with the abilities in manufacturing today, there is no need to come back and true these seat faces up before you install them. The run out that we were able to maintain is much better than obviously years past, to where you can leave these features here and really add some extra benefit, especially during that critical break-in period. So we leave it in place and again upgrade the materials with 23/8 on the exhaust with a high chromium silicon back into the valve, and it holds up really well.
That's extremely critical for the engines have changed so much. Diesel applications is nowhere near what it used to be back in 94 or back in 1990, where we're seeing now not just higher output in horsepower and higher torque numbers, but we're seeing now exhaust temperatures increase due to variable geometry turbo, excessive drive pressures, but also the emission systems.
The AGR is really a contributor to the environment now that they have to go through is so much more extreme, you're right, Cass.
Yeah, that's something that the OEs, unfortunately, I think have found out. I know that Ford did with the 6.7. I know that the expansion rate on the 6.7 Cummins guys, it wasn't something, it's something we've seen a big issue with on that.
Right.
And so that's interesting to see that the valves have changed. Now, for the guys wanting to know what our product consists of, we have the cask watch engine that we call. It's basically for the big-footed driver. So all the cylinder heads from there actually have these nitrided valves in them. So that's just one more component that we actually upgrade. And we're constantly looking. Everything has a fuse. I've got a good friend of mine, Chuck Lynch, that you both know him, great guy, and he always talks about you upgrade this one part, and it's just like if you're in a house and you plug your hair dryer into the outlet, and it's just the one thing that was too many things on that outlet, and it pops the fuse, it trips the fuse. So there's so many things like that in the engine though, where a guy comes in and he puts ARP studs in it and he thinks, okay, that's got it, but then it moves, and it's constantly evolving to the next place. So one of the things that have been really successful for us is the valve seats that y'all make, and using that integrated seat from the factory. Can you tell us some of the benefits that having a press-in seat like that, and some of the alloys that you use, and what the effects that might be on cylinder heads?
Absolutely, yeah. There's, obviously it's got probably more to do than anything with getting the heat out away from that valve. Obviously you've got issues with tighter clearances, tighter than ever due to the oils we're using and emissions. So it's more important now than ever, I believe, to draw as much heat as you can from the head of this valve that's being suffered and tortured within that chamber into the valve seat insert. It's typically going to be responsible for about high 85% of drawing the heat away from this head before it starts to swell up in your stem. And obviously swell the stem, stuck in a guide, galling, and then a potential failure. There's typically some rules of thumb when you're just going in, and you learn this from the old applications that were just a straight portion of the casting was induction hardened, and kind of a formula that we always like to share with the customers. I mean, if you have a pocket to cut, you always want to err on the side of caution. You don't know where the water jack is at, if it's never been tested. People are always calling, can you guarantee you won't hit it? Well, if it's in our catalog, obviously we've tested it. It's tried and true. But you try to end up with about 60 thousandths over beyond the head diameter, and about 150 thousandths ID less than the head diameter. That should give you enough material in there for it to do its job. And materials are going to be, they're going to vary. When you get into light duty gasoline, pass car and truck applications, you're typically going to end up with just a high silchrome valve seat insert. Trade name is similar to what we would use to be like a silchrome XB. Totally suitable for today's modern fuels and usage and performance. When you get into something a little bit more heat related, or you get into turbo environments, or you have something that's a real strain. We figured it and found it with some of the smaller applications in just pickup trucks, where somebody's got a 4-liter Ford and they're trying to pull a horse trailer, a cargo, with it or something like that. It's going to have a lot of heat build up on the exhaust side. So then we go with the nickel-based alloy. We call it our Star Series. The base goes away from iron, goes into nickel, and you're going to have certain percentages above and beyond that with some other elements. But it's going to be a much harder seat out of the package. Certainly a little different to machine, but it's going to have the ability to handle those higher temperatures. Past that, you get into potential CNG usages, something where it's really extreme and really rough, and then you get into your cobalt-based alloys, or people would call them a stellite seat, and you're going to work through that. We use variations with tungsten, and then we also use, again, a lot of that cobalt when you get to that level of severe torture, if you will.
Yeah, that's Yeah, that's you coming away. I remember when I was taking my engines to the machine shop and having doing cylinder head work. I remember the guy calling me. He's a local guy, and he said, "Man, I can't cut these seats. These things are too hard." And he would try to just go in and stone the seat as best he could. The one big issue that we saw was a lot of the cracking would develop from that seat where it was hardened and then spread through the rest of the head. That's basically all but eliminated the issues that we've had by using the press-in seats, because it's maintaining the heat in the area, better, like you say, better dissipation. But one of the things, the guys that are cutting the seats, we've got a certain amount of hardness that we're cutting out. So now, if you're going below that, it only hardens to a certain depth, right?
Well, in our seats, you're going to be much more of a through hardness.
Right.
You really could. We typically don't like to say cut them in half. Mm-hmm. Obviously, the nature of cast, you will have the potential, what would be called the trash area of the seat. Even OEM manufacturers maintain these standards, but it's about a third of the way down and a third of the way over. It should be very, very clean material for you to clean up, use tapers, throat angles, different things like that. Staying away from some of that bottom area. Obviously, you're going to lose a little bit of that integrity because it is so much in the core. Mm-hmm. But then you also do have the tendency, because of the nature of how the process works, is to have a little bit of porosity down in there. Mm-hmm. So we try to steer people to having as close to finished as they can find, but we know a lot of machinists will take a hockey puck and turn it into anything.
Yeah.
And more often than not, it will work, but you always want to err on the side of caution, at least put that little nugget out there that, it might work for 8 of them, or 7 of them, but your 8th one, you might have a little issue, so buy an extra seat if you're going to go crazy and hog them out.
Yeah, absolutely. And, the factory valve seat or the integrated seat, the guys that are coming in, they're cutting that, they're taking away the hardness of that material.
In that instance, absolutely. And you run into a magnitude of issues. Obviously, you're not getting any material back in. Mm-hmm. They're not building a thicker margin on the replacement valve unless you're doing something custom, perhaps.
Yeah.
So, then you start another, as you said, a fuse where, you're going to have a cause and effect and a ripple effect with geometry and things of that nature. Spring pressures are going to be affected.
Right. Well, just using the example that we've got right now with the 6.0, 6.4, I can't begin to tell you how many times I've had people talk about lifter failure, or people that'll buy a short block from us and they'll call us and say, "Hey, I've got low compression," and they don't realize that their machine shop just whacked the top of that head, the surface of the head off. So now you're changing the geometry of the engine itself. You're moving, in essence, the cylinder head closer to the center line of the crankshaft. So everything's coming more condensed. The problem with it is that 9-inch 800 push rod, or 9-inch 849, depending on what year and everything that you've got, it's not changing.
No.
And you start running into issues, just like we were talking about. You can't do one thing that doesn't affect 100 other things in an engine.
That's right.
So now we've changed the preload, like we were talking about earlier, on the lifter. Whereas the lifter failures have been really, really prevalent with the 6-liter industry. And there's multiple reasons. We've done podcasts before on some of the causes of the failures from that, be it ramp angles, and Billy Godbold at Comp. We worked with him to develop crack and wax style cam that really helps with valve train geometry and harmonics. But when you've got a guy in there that's changing geometry to things, which, so many people take the cylinder head off, they take it straight to the machine shop, and the machine shop, they've got an old Storm Vulcan in the corner. Oh yeah, we can do that, and they don't think about the relationship, the casting thickness, and what the preload's going to be on that lifter.
Right.
Yeah.
And as you mentioned before, if you take that lifter out of its sweet spot, and we've all agreed, you said about 60,000, which you like to run here preload, it's just not going to function the way it was intended.
Right.
It's a valve gear. It's called a valve gear because they're all in relation to one another.
Right.
And they've all got to maintain concentricity and to have the original geometry in place for it to function, at least long term.
Yeah. Let's talk about a little bit of the nomenclature of the valves. Now we've talked about what that means for the guys listening. I know that the stock valves are pretty much most of the time. Now, you saw talk about Cummins valves, the N and the nomenclature that it stands for. Some of our listeners might have seen that when they pull their cylinder heads off and wondered, what does that mean?
Right. A lot of times you'll see a dimple, a tool mark that's typically just going to be for the fixturing of the finishing processes of the valve. Many manufacturers do like to put some sort of, as I said, nomenclature, a letter, a dot, You're going to have anything as random as 2 dots or a line in it indicates what plant it was manufactured at. So it may not mean a whole lot to you or I or anything, anybody out there installing them. However, Cummins is pretty clever when they do work with the letter on top of the head. I think your ends are going to be a high-grade stainless steel, which would be like a 23/8 end. The O's are always going to indicate an Inconel. So they do have some clues on the valves. It does become very important when you're working on the Cummins because they start them with a basic 2 sets of valves. If you're just a daily driver and that vehicle was slated with those two valves, fairly low horsepower ratings, things of that nature, you're going to have a basic chrome steel intake and a entry-level intake valve or exhaust valve. 21/4 inch, typically 2-piece valve with a chrome silicon on the back end. If you pay attention though, if you're trying to pull anything, if it's ready for a little more usage, you're going to start seeing the letters in the top of the head. You're going to have an N there. That's going to indicate that you need the 23/8 N. You're subjecting it to a little harsher environment. You're using it for what the truck was intended for. You're going to want to upgrade and or replace with that valve. If you see an O in the top of your head, that's even the highest grade that they're going to offer. It's people pulling horse trailers, maximum duty applications, and you're going to want to go back in with that. Anything less is typically going to not suffice, and you're going to be potential failure down the road.
Gotcha. So that's going again, people ask us all the time, the different models, what are the differences? And sometimes they're subtle because most of the guys, they want to know, okay, has it got billet rods in it? Yes or no? I mean, those are major alterations that you're thinking about in terms of, how much horsepower can this thing actually handle?
Right.
But a lot of times the valve train's just absolutely forgotten about.
Absolutely.
Well said.
Absolutely. And I think, again, for anybody who's pulling them out, we have people all the time that'll call and say, well, I don't know, I've got the arrangement number or I've got a serial number on this thing. Tell me what valve it goes in. I said, well, when you tore them down, did you, take a look? So I think it's very important for tear down guys in a lot of these applications to save them or photograph or at least keep a piece in hand for that, you take it for granted. Well, you just look in the SBI book or in the competitor's catalog and say, okay, application, make, model, and here's the valves. Well, in many of these valves, in applications in this day and age, there might be 3 or 4 different exhaust valves to choose from and a couple of different intakes. So it is very important to save a couple pieces, whether it be a dimensional change or as simple as just a letter on the top of the head or a dot will give us a little bit of understanding of what you're looking for and lead you down the right direction with the right replacement part.
Gotcha. Well, if it's good enough for Cummins, obviously, they're not using the same one-size-fits-all.
Right.
Then, people need to stand up and take attention to that. And that's the reason why, again, we're talking about the different models in our engine. So we've got the Model C, the Daily Driver, the Workhorse, and then the Casquatch, which is pretty much the race series engines. Those are all things that are, we pay attention to that here. And when we're speccing out an engine, we're not just saying, hey, we want this type bearing, this tensile strength, this rod, this connecting rod, bolt, whatever it might be. But the valve train is really one of those things that just take more beating than anything else, but it's the most neglected. Guys think of valve train and there's one thing that they think of. What's the valve spring pressure?
Right.
And that's the end of it. They don't think about the seats or the guides. But talking about guides, so many guys talk about this in the diesel world, and I definitely want to get your take on it. People, your expertise. The bad thing about it is that on the internet, everybody has an opinion and it's equal.
That's right.
It shouldn't be, because there's experience that goes behind when you're talking to a guy like yourself or like Phil, face to face. These guys, y'all have spent years and your whole lives in the automotive industry, and getting that good solid content. That's the reason why we do these podcasts and we do these videos, is so that people can actually have a chance to speak with or listen to the pros in their field. An 18-year-old kid, no disrespect, but he hasn't lived long enough and hasn't seen enough necessarily to be on the same footing as Warren Johnson or somebody like that, in the racing industry or wherever it might be. But valve guides, there's a lot of talk in the diesel world about a bronze guide versus a matrix valve guide. Tell us a little bit about that.
We've not to this point cataloged or done a whole lot of research on, say, a solid state bronze guide. SBI only offers manganese bronze guides. just through our research and studies and trials, that we find it to be a superior alloy versus the silicon bronze. And I know there's going to be a lot of back and forth that way, because everybody has their own opinions about that as well. But I can only speak for what we've found and our direction. So we do offer those for gasoline applications, LS heads, small block, big block applications, but we've never dipped our toes in the water of adding them to a diesel application. Obviously there's merit. Bronze has built-in lubricity on a elemental level that is going to keep things conditioned and running smoothly. I don't know that I really would go down the road of adding a solid state. I do know that the K-line guideliners that we do offer have become very, very popular. And I don't know they're going to get the longevity as a solid state valve guide. They might have they are interrupted spiral. They're going to have some oil retention qualities to them and the built-in lubricity, but you're still talking about a fairly thin-walled liner that is going to have a wear point eventually.
Right.
So again, we with our understanding with the valve guides and the intellectual property that we had acquired from the Eaton Corporation, or Ertl Corporation, excuse me, we've got a vast variety of alloys to choose from. And so anything probably within the last 10 years, gray iron is out. We just don't use a gray iron anymore. It typically will work in today's modern gasoline engines, but we do use a high tensile strength alloy, something with a little higher hardness. In certain applications, we like to heat treat them. Other applications will add a phosphate coating to aid in that initial break-in period. We're cast people. We like the solid state guides, and I really believe the longevity is still going to be there with that type of product.
Yeah, I have personal experience from that. I mean, I've used it in local machine shops. Again, local machine shops, going back to the days of piston knurling, and there's always that guy that's going to skip a step, and there's a lot of guys that are probably out there listening, going, you get everybody. You mention that to somebody that knows, and they grin, and they go, ooh, that probably wasn't the best idea doing it, but back in the day, that was the thing to do. And there's a lot of things that happen. Same thing with different components. Still, some guys are still actually knurling.
I hear that.
Yeah. I cringe when I hear it. I really do. But there's so many things. The bad thing about a machine shop, and I say this all the time, for a guy that doesn't really know, it's black magic. You're just taking your engine up there and in good faith thinking that this guy, he's been doing it for 40 years out of his backyard. And nothing, no disrespect, there's plenty of guys out there that do good work, but there's many of them that do good work. There's probably twice as many of them that are looking to skip that step. And a lot of those spiral guides that we've seen, personally, my experience has been that they are they have not had as good as success with that. It's a cheap, quick way to get it out the door.
Sure.
And it's cheaper for the machine shop to install a spiral instead of core drill reaming. Which is the original valve guide, and most cylinder heads nowadays are cast into the cylinder head itself. In order to replace one of the guides like Ron has in his hand here, this actually, and this will segue into one of the questions that we were asked. In order to be able to replace this, you can actually see on the camera that there is a kind of a top hat or a counter shaft here that is a little bit larger, and what that does is that allows us to know and set our depths consistently. But the problem with it is the factory guide is cast into the head, so that when it wears out, now you have to literally plunge cut this thing with a drill and then ream it right behind so that this fits properly. The issue that guys run into is a lot of machine shops don't want to take the extra step to go into cutting all this out because it's labor intensive. So instead of attacking the OD and building back concentricity and the things that they're doing, they're going to install a spiral guide inside the guide itself and the idea of the guide, which makes it. There's a couple of problems with that, like you mentioned, the wall thickness. Anytime you take a piece of material, you start thinning.